Welcome back to the Fabric of Life, where we like to untangle all those fascinating threads of biology.
That's right.
And today, we are diving deep into fibrinogen,
Yes.
a protein that's absolutely crucial for blood clotting and wound healing.
Keeps us from bleeding out from a paper cut.
Yeah, that's the one.
That's a pretty important one.
So let's start at the very beginning.
Sure.
How did we even discover this wonder protein?
So the journey really begins with fibrin,
Okay.
which is the actual clot material. And scientists way back in the 1600s
Wow.
noticed this fibrous substance in blood.
Okay.
But it wasn't until the late 1800s that they realized that fibrin wasn't just, appearing out of nowhere.
Right.
It was being formed from a soluble precursor in blood.
I see.
And that precursor is fibrinogen.
So it's like a secret agent transforming when it's needed.
Exactly.
I like that analogy.
It's a good one.
So fibrinogen itself is a pretty complex molecule, right?
Oh, absolutely.
It's not just a single protein.
No, it's a hexamer. So it's made up of 6 parts.
Wow.
2 sets of 3 different chains.
Okay.
Alpha, beta, and gamma.
Got it.
All intertwined and held together by disulfide bond.
Like a braid.
Like a braid, exactly.
So how does this braided protein turn into a clot when we get a cut?
Well, that's where things get really interesting.
Okay.
We have thrombin,
Okay.
which is an enzyme, and it snips off these little tiny bits called fibrinopeptides
Okay.
from the alpha and beta chains of fibrinogen.
So it's like giving it a haircut
it is exactly.
to reveal its true potential.
Exactly. And that haircut is really crucial because it exposes these sticky ends on the fibrinogen molecule, allowing them to bind to each other and form long fibrous strands.
Okay.
And those strands are fibrin,
And that's the building blocks of a clot.
the building blocks of a clot. That's right.
But isn't fibrin kind of a soft, jelly-like substance at first?
Yeah, the initial fibrin clot is pretty flimsy.
Okay.
It's like a temporary scaffold. And so that's where factor 30 steps in.
Yep.
It's the reinforcement crew.
Okay.
And this enzyme kind of weaves those fibrin strands together, creating these covalent crosslinks that make the clot strong and stable.
So it's like adding steel beams to a building
Perfect analogy.
to give it that structure.
Yeah, so it goes from this kind of wobbly structure to something that's really solid and resilient.
And this all happens super fast,
Oh,
right?
yeah, in a matter of minutes.
Wow.
Yeah.
That's amazing.
So even a small cut doesn't turn into a major bleeding event.
It's mind-blowing how our bodies just kind of do this without us even thinking about it.
Right. It's incredible.
All these intricate systems working to keep us safe.
And, speaking of keeping us alive,
Yeah.
fibrinogen's importance goes way beyond just humans.
Oh, really?
Yeah, it's remarkably conserved across a vast range of species.
Like what?
I'm talking mammals to fish.
Oh, wow.
Which suggests that the basic mechanism of blood clotting has been around for hundreds of millions of years.
So it's a real evolutionary success story.
It really is.
So does that mean that all creatures, even little insects, rely on fibrinogen?
Well, that's where things get a little bit more nuanced.
Okay.
So while fibrinogen is widespread in vertebrates,
Uh-huh.
we haven't actually found a true fibrinogen ortholog in lower organisms like insects or worms.
Hmm.
Yeah, they seem to have developed different clotting mechanisms,
Interesting.
maybe reflecting the different pressures and challenges they face in their environment.
That makes sense.
Yeah,
So fibrinogen kind of evolved later on
it's a possibility. Yeah.
as organisms became more complex.
Yeah, it's really fascinating.
So many questions.
It is.
Well, let's shift gears a little bit and talk about how these amazing molecules are made.
Okay.
Where do those alpha, beta, and gamma chains come from?
So that takes us into the world of genetics.
Okay.
Each of those chains has its own blueprint, a gene that encodes the specific sequence of amino acids that make up the protein.
So like a set of blueprints,
Think so.
one for each chain.
That's right.
Okay, cool.
The alpha chain is encoded by the FGA gene,
Okay.
the beta chain by the FGB gene,
Uh-huh.
and the gamma chain by the FGG gene.
Makes sense. So we have these genes churning out these chains.
Right.
And then they just assemble into this perfect hexamer.
Well, not magically, but it is a remarkable process.
Okay.
So these chains are synthesized in the liver,
Okay.
and then they undergo a series of modifications and assembly steps before being released into the bloodstream as functional fibrinogen.
What kind of modifications are we talking about here?
So one of the key modifications is glycosylation,
Okay.
which is where sugar molecules are attached to specific sites on the chains.
So it's like adding little tags.
Little molecular tags that can affect how the protein folds,
Uh-huh.
interacts with other molecules, and even how stable it is in the blood.
So these sugar tags are really important for fine-tuning.
Exactly.
So it's ready for action.
Exactly.
Now that you mention it, I've heard that there are quite a few conditions that can arise from problems with fibrinogen.
Yeah, there are.
So what are some of the most common ones?
One is called dysfibrinogenemia,
Okay.
where the fibrinogen molecule itself is structurally abnormal.
Hmm.
This can lead to bleeding problems or an increased risk of clotting,
Oh, wow.
depending on the specific abnormality.
It's like having a faulty blueprint.
It is a great way to put it.
That makes a wonky fibrinogen
Exactly.
that can't quite do its job.
That's right.
And then there's hypofibrinogenemia,
Yeah.
which is just a deficiency in the amount of fibrinogen
Exactly.
circulating in the blood.
Right. So there's not enough to form those clots.
And I imagine that having no fibrinogen at all would be catastrophic.
It is unfortunate.
Not even possible.
Yeah. It's called a fibrinogenemia.
Wow.
And it's a very serious condition that can cause life-threatening bleeding episodes.
It's incredible to think that something like a blood clot can be so crucial to our health.
It really is.
It's all about that balance, isn't it?
Exactly.
Well, this intricate interplay between
Yeah.
fibrinogen and health has spurred a lot of research into potential therapeutic applications.
Absolutely.
So let's talk about treatments.
Okay.
What's the current state of the art when it comes to addressing these fibrinogen-related disorders?
Well, for deficiencies, the mainstay of treatment is fibrinogen concentrate,
Okay.
which is essentially purified fibrinogen derived from human plasma.
Got it.
And it can be administered intravenously to boost clotting ability.
So it's just a direct replacement therapy.
Exactly, providing that missing ingredient.
Exactly.
And it's been a lifesaver for many individuals with severe fibrinogen deficiencies.
That's great.
But there are also ongoing efforts to develop more targeted therapies,
Oh, really?
like drugs that can modulate fibrinogen activity
Oh, wow.
or even gene therapies that could correct the underlying genetic defect.
That sounds promising.
It is.
So are there any drugs that are currently available that target fibrinogen?
There are. We have anticoagulants,
Okay.
which are drugs that inhibit specific steps in the clotting cascade,
Okay.
often by targeting thrombin, the enzyme that's responsible for converting fibrinogen to fibrin.
So they're like putting the brakes on the clotting process
Exactly.
to prevent unwanted clots from forming.
Exactly.
And on the flip side,
Yes.
we have thrombolytic drugs, which dissolve clots that have already formed.
That's right. And those are often used in emergency situations like stroke or pulmonary embolism to restore blood flow.
It sounds like we've come a long way in our understanding of fibrinogen.
We have.
And our ability to manipulate it.
Absolutely.
For therapeutic purposes.
Yeah.
But I imagine there are still a lot of challenges and unanswered questions.
Absolutely. Fibrinogen is a complex molecule with multiple roles in the body.
Right.
And manipulating it therapeutically requires a very nuanced approach.
Yeah.
So we need to carefully balance the benefits of preventing or dissolving clots with the risks of interfering with other essential processes like wound healing.
It's a reminder that our bodies are just these incredibly intricate systems.
They are.
And even the smallest change can have huge effects.
Exactly.
Yeah, that's what makes fibrinogen research so fascinating.
It is.
It's like peeling back the layers of an onion.
I like that analogy.
And with every discovery, we just uncover more questions.
More complexity.
Yeah, it's great.
So what are some of the most promising areas of research right now in this field?
Okay.
Where are scientists focusing their efforts to unlock even more of fibrinogen secrets?
So one area that's particularly exciting is the development of more targeted and personalized therapies.
Okay.
So this could involve using genetic testing to identify individuals who are at risk for specific fibrinogen-related disorders.
Okay.
And tailoring treatments to their unique needs.
So moving away from the one-size-fits-all approach.
Exactly.
And making things a little more precise.
That's right.
I like it. Another area of active research is exploring the potential of fibrinogen as a biomaterial.
Okay.
So its natural ability to form these strong biocompatible scaffolds makes it a promising candidate for tissue engineering and regenerative medicine applications.
So using fibrinogen to build tissues or even organs.
That sounds like something straight out of science fiction.
It might sound futuristic.
Yeah.
But it's closer than you think.
Oh, wow.
Researchers are already using fibrinogen-based materials to create artificial skin grafts.
Wow.
Blood vessels, and even cartilage.
So it's really amazing to think that this blood clotting protein could hold the key to such groundbreaking medical advancements.
I know, it really is a testament to nature and the power of scientific inquiry.
Absolutely.
And I think this is just the tip of the iceberg.
I think so too.
When it comes to the potential of fibrinogen.
Yeah.
As we continue to delve deeper into its mysteries, who knows what other amazing discoveries await us.
Absolutely. And we'll be here to cover them.
Sounds good.
All right. Thanks for listening, everyone. And we'll catch you next time on The Fabric of Life. See you later. #